We are up against a strict physical deadline. The world has to rapidly reach net zero carbon emissions to prevent global temperatures from crossing dangerous, completely irreversible climate tipping points. In the West, there is a common public assumption about how this gets solved. We tend to think the wealthiest, historically industrialized nations are the ones leading the charge to save the planet. The actual data contradicts this. Right now, the nation historically responsible for the highest share of global emissions is actively pouring federal money into expanding its fossil fuel footprint. Meanwhile, the country currently manufacturing almost a third of the world's physical goods is building out renewable energy at a pace that exceeds global records every month. To understand the true path to net zero, we have to look past historical assumptions and diplomatic rhetoric and measure the physical infrastructure actually being built today. Look at the United Kingdom as a baseline for getting this right. In 2024, they officially shut down their last operating coal plant. But phasing out coal is only step one. The baseline requirement for clean energy is a capable grid. The UK is investing up to £90 billion by 2031 to upgrade its electricity and gas networks to handle heavy renewable loads. They backed up that grid expansion by successfully deploying 51 operational offshore wind farms. Because of that physical infrastructure, paired with a network of subsea interconnectors, the UK generated so much power in 2022 that they became a net electricity exporter to Europe for the first time in 44 years. It proves that a legacy industrial economy can successfully decouple from fossil fuels when they commit the capital to heavy grid and offshore upgrades. Then there is China. As a baseline, China requires a staggering amount of energy because they manufacture nearly 29. But they are rapidly changing how that massive industrial demand is powered. In April 2025, wind and solar generated an astonishing 26% of all their electricity. This bar chart compares their scale directly to the UK. While Britain has an impressive 51 offshore wind farms, China currently operates 138 of them. Onshore, the footprint is even larger. The Gansu wind farm is the largest in the world, visible from space and powering 15 million homes. Their installation velocity breaks records constantly. In May 2025 alone, China installed 93 gigawatts of solar and 26 gigawatts of wind. That is enough physical infrastructure built in 30 days to power entire European nations. That hyper-rapid build-out allowed China to surpass its government target of 1,200 combined gigawatts a full 5 years early. And India is following this exact same blueprint, now generating 22% of its total electricity from renewables, with over half of its total capacity coming from non-fossil sources. Asian manufacturing superpowers are now the primary engines of the global energy transition, deploying green infrastructure at a volume that dwarfs Western efforts. Compare that rapid physical progress to the United States. To understand the U.S. position, we have to look at historical carbon debt. This area chart tracks cumulative historical emissions. The United States generated 25% of all global CO2 since 1750. That is over 400 billion tons. Despite carrying the largest historical carbon debt on the planet, the U.S. has exactly 3 operational offshore wind farms. And instead of mobilizing a green transition, the federal government is heavily backsliding. They recently allocated $625 million in funding to modernize and extend the life of aging coal plants. At the same time, the White House is opening 13.1 million acres of federal land to new coal mining excavation. The nation with the deepest carbon debt is expanding its legacy fossil fuel systems instead of funding the physical green infrastructure required to replace them. The global shift to renewable energy has moved beyond diplomatic talking points and environmental pledges. Success now depends on a high-stakes industrial race, where progress is measured by the sheer volume of steel, silicon, and physical gigawatts being deployed across the landscape. There are still massive engineering hurdles to clear, specifically the need for enormous battery storage networks to stabilize the grid when the wind drops or the sun sets. But climate pledges and target dates mean zero unless actual gigawatts of clean electricity are physically connected to the grid. If we are going to avoid catastrophic climate tipping points, legacy-emitting nations have to permanently abandon fossil fuels and match the staggering industrial scale of the current renewable leaders.